Hello, in this video I will show you how to use the IBM SPSS software to run some procedures that rely on the t-statistics. Specifically, I'm going to demonstrate how to calculate a confidence interval for the mean and also how to run a one-sample t-test, a paired samples t-test, and an independent samples t-test. In this data set, we have 40 individuals, a group of 40 students, and we have the gender information for these students. Gender was coded 0 for males and 1 for females. And we also have scores on test 1, which is a pre-test, and scores on test 2, which is a post-test. Let's say that the instructor of this course is interested in knowing the average score on test 2 and also the 95% confidence for the mean on test 2. So to do this, I can simply run some descriptive statistics. I could go to Analyze and then Descriptive Statistics and Explore. I'm going to reset this because I ran it before. So from the list of variables, I'm going to select test 2 and move it into the dependent list. If you want to change the level of confidence, all you have to do is go to the statistics button, and then in the confidence interval for the mean, you can type in a different confidence level. In our case, we're interested in the 95% confidence interval, so I'm just going to leave it as it is and click continue and then click OK. In my output window, I now have the descriptive results. I can see that the mean score on test 2 was 78, and the 95% confidence interval for the mean was between 75 and 81. So what this means is that if we were selecting multiple samples, multiple random samples, very similar to the one that we already have, and we're calculating the mean for each one of those samples, in 95% of the cases, the mean would be between these two values. So we can say with 95% confidence that the population mean on this test is between 75 and 81. Okay, another way to calculate a 95% confidence interval is to do it from a one samples t-test procedure. So we can go to Analyze, Compare Means, and then one samples t-test. Again, I'm going to reset the values. From my list of variables, I'm going to select variable test2, move it into the test variables section. I'm going to leave test value 0 here. Again, if you want to change the confidence level, you can go to the options button and change the level of confidence. I'm going to leave 95% for us, and I'm just going to click OK. Because the test value is 0 here, we're basically testing whether the group mean is significantly different from 0, but that's not what we're interested in here. What we're interested in is just looking at the 95% confidence interval, which is again between 75 and 81, just like we've seen before from the descriptive results. Okay, let's move on to the next question. Let's say that the instructor of the course wants to know whether students have made sufficient progress from the beginning of the course, from their pre-test, which was test 1, to test 2. To do this, we run a paired samples t-test. So we go to Analyze and then Compare Means, and then paired samples t-tests. I'm going to reset the values again. For variable 1, I'm going to use test 2. And for variable 2, I'm going to use test 1. So this is going to calculate the difference between test 2 and test 1. And I'm going to click OK. I can already see here in the results that the average score on test 2 was 78, the average score on test 1 was 79, but was this difference statistically significant? To find out, I'm going to look at the results of the paired samples t-tests. Specifically, I'm looking at the t-statistic, which is 7.8. and the p-value for the statistic. The p-value is lower than 0.001, both for the one-sided and for the two-sided alternative hypothesis. Remember that the instructor was interested in knowing whether there was enough growth from test 1 to test 2. Students have received instruction after taking test 1, so we have reasons to believe that their scores have increased from test 1 to test 2. So our alternative hypothesis is one-sided because our question is whether scores on test 2 are higher than scores on test 1, not higher or lower, just higher. So every time we're testing for growth, the alternative hypothesis is one-sided. So I'm going to use the one-sided p-value, which tells me that I should reject the null hypothesis. The null hypothesis was that there was no significant difference between scores on test 1 and scores on test 2. Okay, moving on, let's say that 60 is the cutoff value between meeting the criteria for the course and not meeting the criteria, or say that students who have scores below 60 are failing the class. So the instructor wants to know if on average students have met the mastery level or have scores above the value of 60. So to do this, again, I'm going to run a one samples t-test. So I'm going to go to Analyze, Compare Means, one samples t-test. But instead of the test value 0, I am going to type in 60 because that's the value that I am interested in. And then I click OK. I see here that the one sample t-test had the test value of 60, and the t-statistic for this test was 11.7 with the one-sided p-value of 0.001, a two-sided p-value of 0.001. So again, my null hypothesis was that scores on test 2 were not significantly higher than 60. There was no significant progress. My alternative hypothesis was that the average score on test 2 was significantly higher than 60. Because the p-value is so small, I'm rejecting the null hypothesis and I am accepting the alternative, which means that scores on test 2 were indeed significantly higher than 60. So 78.17, which is the mean on test 2, is significantly higher than 60. Another question that the instructor may have is whether scores differ significantly by gender. To do that, the instructor needs to run an independent samples t-test. So we go to Analyze, again, Compare Means, Independent Samples t-test. I'm going to reset values again, and then select test 2 as a test variable. And then I'm going to select gender as a grouping variable. After selecting the grouping variable, we have to define the group, which means telling SPSS how these groups were coded. So we use 0 for males and 1 for females. And then click Continue. And then click OK. I now have in my output window the results of the independent samples t-test. I can see the mean for males is 74. The mean for females is 81. I can already tell that females have a higher average score, but is this difference statistically significant? To find out, I am looking at the results of the t-test at the t-statistic, which is negative 2.192. The one-sided p-value is 0.017, the two-sided p-value is 0.035. In this case, the null hypothesis was that there was no significant difference between the groups, or that the mean of the two groups was roughly equal. The alternative hypothesis was that the mean of the two groups was significantly different, without specifying, however, which group would have a higher or lower mean, because we have no reason to assume that one group would have a higher mean than the other. So we're just thought they might be different. The alternative hypothesis was therefore two-sided. So in this case, I'm going to use a two-sided p-value, which is still lower than 0.05, still lower than my alpha. So I'm still going to reject the null hypothesis and accept the alternative and say that the difference between the two groups is statistically significant. So in this video, I demonstrated how to run different procedures that are relying on the t-statistic. These procedures were the 95% confidence interval, a one-sample t-test, a paired sample t-test, and an independent samples t-test.